Good afternoon, guys. Now, my video presentation for today is about finding graph due to change of density by using hydrostatic tables. Okay, so let's begin, guys. So the topic again is finding graph due to change of density by using the hydrostatic table. So by this example, it says here, find the graph of the same displacement in different water densities. So the vessel is a Panamax vessel, and the mean graph is in salt water is 13.29. Find the mean graph in dark water density of 1.013. Okay, so convert what will be the mean graph if the ship is floating in a density of 1.013. So this is a simple solution. So the mean graph of the displacement of 13.29 is 78817. So step 1, it says calculate the volume of water to displacement of 1.013. So the formula is volume weight over density. So the volume of displacement, which is 78817 divided by 1.013, and the volume of displacement is 77805.5. Okay, so this is the volume of water displaced and underwater volume of the ship. Okay, so this is the water volume of the ship, underwater volume of the ship. Okay, that will be the volume displacement. And step number 2, look up the graph that corresponds to the underwater. So underwater volume by multiplying the volume by 1.025, meaning this volume of 770805.5, multiply it by 1.025 to get the graph. So here, look up displacement is underwater volume times density, and the look up displacement is equals to the volume underwater displacement is this one, 77805.5 times the density of 1.025, and the lookup displacement will be 79750.6, and corresponding graph would be 13.435 if we are plotting at the density of 1.013. Okay, and here this lookup displacement corresponds to the graph of 13.435, this one. At this graph, the underwater volume is 77805.5, which is equal to the volume actual displacement of 77817. This is this one. Okay, which is equal to the volume of the actual displacement of 78817 when the density is 1.013, this one. Okay, the above calculation can be shortened to, so look up this look up displacement. This is the present displacement times 1.025, which is this one, over the duct water density or the local density, which is 1.013. So the present drop or the present displacement would be this one or this one, corresponding drop of the 13.29. So that is your present drop times your constant of 1. Seawater of 1.025 over your duct water or local density is 1.025, and local displacement will be 79750. This will be, and if you look at this at the hydrostatic table or the value of this one, you will get the 13.435. Okay, so we'll just investigate, guys. Okay, so the present drop is 13.29 with this displacement. So we'll use the program. We go to 7 and here, so we have 13.29, then 13.29 with a density of 1.025. Okay, now what will be his drop when you ship loads in a density of 1.013? Okay, look at his displacement is 78818 of this drop 72. Okay, we just see it, guys. Displacement is 78817. Okay, so 78818, almost the same. Now if we floats in a density of 1.013, what would be his displacement and drop? So his displacement will be 79751. His displacement will be 7975150, and his corresponding draft will be 13435. Okay, 1435. See, so from this draft of salt water of 1.025, if she floats in a density of 1.013, and there will be a change of displacements, which is 79751, and his draft will change to 13.435. Okay, take note, guys, when she was floating in a salt water of 1.025, the drop is 13.29. remember, if the density is less than 1.025, which is now less, is 0.13, which is less than 1.025, he will have an increase in the draft. The vessel will sink down, meaning there will be a large change in the draft. So the draft will be 13.43, while the at seawater is 13.29. So he will sink more when his density is less than 1.025. He will have an increase in the draft of 13.435. Okay, so that's it, guys. Then there's another example here. Okay, then we go to another one. Okay, this one. So with this corresponding displacement, look up displacement, he will get a draft of 13.35. Okay, so we have another example here. The MV Max Panamax present displacement is 7080. Using the ship's hydrostatic table, find the draft if she floats in a density of 1.012. So with this present draft, what will be with present displacement? What will be his displacement when she floats in 1.012? So the formula here is lookup displacement is this present displacement, which is 7080, multiplied by the constant of 1.025 of salt water over your present our new density is 1.012, and the new displacement will be 78070 if he floats in the seawater of density of 1.012. So we'll just investigate this with the program. Okay, 700 7080. So 7080, we'll just proceed here. 77080. So with this displacement of 70080, this drop, corresponding drop, will be in seawater, it will be 13.020. Okay, so with 13.1302 there, go to 1302. Okay, 1302, 13.02, 13.02, and look at his displacement is 70081. What we have is 77080. So 1 ton difference to sake of computation. And what will be his graph when his density is 1.012? Get this 1.012. So 1.012, his displacement would be 78070, and his drop would be 13.174. So let's check. The drop is 13.174, and his new displacement or lookup displacement is 78070. 78070. Okay, so that's it, guys. If you don't want to use this program, well, use this you can use this manual computation, but here you will need the program, or you need to interpolate to get this drop. So let's say 7807 7807 7807 7807 7807. So you will get this interpolation of 13 meters and 13.2. So that will be, so you get 13 and 13 meters and 1320. So that will be here, guys. You go to the table. 1320 and 13 meters and 1320. So it's in between this one. So you interpolate. See, 13 is 76952. 76. See, how much is the 78070 78070. Okay, so here 13 meters is 76952. 13 meters is 76952, and 13 meters and 20 is 78238. 78238. 78238. Here, guys, 78238. So you interpolate this one, then you get the value of 13174. 13174. So you can visit the hydrostatic table and interpolate, but by using the program, here yan, using the program, you don't have to interpolate. Just put this density, the draft, then you will get the results of your new density and your new displacement and your draft. Okay, so that's it, guys. If you like, here, that will be J7, which is this one. Okay, so if you like the video, please click the like button, share, and subscribe. And have a good day. Thanks for watching.